Okay, just want to pick up where we left off with the last video. We had just done chlorine as an example. The next example I want to do is Ga, gallium. So I'm going to bring up my periodic table again. I'm going to find gallium on my periodic table, and it's right here, kind of right in the corner where the D and the P block meet. So it's in the 1, 2, 3, 4th row down, and then all the way at the edge of the P block. So then I find that on my map, 1, 2, 3, 4, all the way to the left side of the P block. So it's right here. Ga is right there. Again, I start at the beginning of the periodic table, 1s. That's my first code I hit, and then I count how many 1s boxes there are. So 1s is my first code, and I count how many boxes there are. There are 1, 2 1s boxes. So I put a little 2 up there. I'm done with that row. Next row is the second row of the periodic table, and the first code I hit is 2s. And then I count how many boxes there are. There's 1, here's 2. So 2s, 2. I go straight across. Where's my cursor? There it is. Go straight across. The next code I hit is 2p. And I count how many boxes. 1, 2, 3, 4, 5, 6. Done with that row, go down to the next row, 3s, and there are 2 boxes, so 3s, 2. Go straight across, next code is 3p, and there are 6 boxes there when I count them up, so 3p, 6. Next code I hit is 4th row here, 4s, and there are 2 boxes, so 4s, 2. Now one thing I want to talk about real quick, if you notice, this is 4s, and this is 4p, but the D block is always 1 less than the S or the P block. And what it is as you start filling up electrons, you know, we add 1, we add another electron, we add another, and we build up to gallium right here. As we keep adding those electrons start going into the 4th energy level in that s orbital, and then the d orbital of the 3rd energy level, the 3rd ring, and the 4th ring kind of overlap. So the inner side or inner edge of the 4th ring and the outer edge of the 3rd ring kind of overlap. So it starts filling up the 4th ring, and then goes back and fills in the rest of the 3rd ring, and then goes back and fills in more of the 4th ring. The main thing you just got to remember is the D block, the block in the middle here, is always 1 less than the S or the P. So again, I was at 4s, continuing on with the gallium example here. 4s, and there's 2 boxes. The next code I hit is 3D, and if I count up those boxes, there's 10 of them. So 3D, 10. And then gallium, if you remember, is that first box right here. So it's 4p, and it's the first box, and I write 4p1. This is one of those cases in chemistry where we have to write the 1. You know, sometimes in chemistry you have to, sometimes if you do it's wrong, sometimes if you feel like it you can, if you don't feel like you don't have to. This is one of those cases in chemistry where you have to write that 1, otherwise you can't just leave it blank. You have to write that 1. So that right there is the electron configuration for gallium, Ga. So I'm going to pause it real quick here, and what I want you to do is do the electron configuration for calcium. So what I want you to do is pause the video, try calcium on your own, and when you unpause it, I'll go over it. So take a second, pause the video, try calcium on your own on a separate piece of paper, and, or I guess write on the notes too if you wanted to. And when you're done, restart it and we'll go over it. So, hopefully you paused it and you tried it on your own. It's important that you try these on your own and you can check your answer here. I'm going to bring up the periodic table. I'm going to find calcium. Calcium's right here. 1, 2, 3, fourth row down. Second one in. So 1, 2, 3, 4. It's right here. So again, starting way back at the beginning. 1s, and there are two 1s boxes. The next row, 2s, and there are 2s boxes. Go straight across. I get 2p6, 3s2 is the next part of the electron configuration, this code that we're learning how to write. The next straight across from that is 3p, and there's 6 boxes there. And then again, calcium, Ca, is right here, fourth row, second box in. So 4s, and it's a second box, so 4s2. If I had done potassium, which is right here, 4s1, the first box is 4s, I would have written 4s1. But since calcium's the second box, I wrote 4s2. So I want to talk about this electron configuration and what exactly it tells us. So this big number in front, as you can see up here, is the energy level. So that first ring of the periodic table, so again, thinking of the Bohr model, and it's got the nucleus in the middle and those rings of electrons around it. The first ring has 2 electrons. The second ring, notice there's 2 2s here. The second ring has 8. 2 here in the s orbital, or the s sublevel, and 6 in the p sublevel. So a total of 8. Third ring also has 8. And then the fourth ring only has 2. So again, these electron configurations tells us where exactly those electrons are. First ring has 2, second ring has 8, and they're divided up into 2 orbitals, the s and the p orbital. Third ring has 8, and again they're s and p orbital. And fourth ring has 2. So, next up is a kind of shorthand version of this. So this is what I refer to as a longhand electron configuration, and there's a shorter way to do it. Like if you were going to do lead, which is right down here, you would not want to do that whole thing. You would want to start all the way up at 1s and build 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, blah, 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 all the way down to lead right here. That would be a pain in the butt. So there's a shortcut, and that's what I'm going to show you next. So this is the shorthand. You can read that over. It might kind of help you if you get stuck, but let's just jump in and do a couple examples. The first one here is phosphorus. So just like before, I find phosphorus. It's right here. It's the third row, fourth one in. Now, with longhand, you always start it back at hydrogen. You start at the beginning of the periodic table and you build across. And you go across. And you go across until you get to where you need to be. With the shorthand, you don't start at the beginning. What you do is, if we're doing phosphorus right here, go up a row and all the way to the right. And this is where you start. So, again, phosphorus is right here. And what I'm going to do is I'm going to go up a row and all the way to the right. Instead of starting at hydrogen, I'm going to start at neon right here. And the way I show that is I put it in brackets. Now notice these are square brackets, they're not parentheses, so there's a difference here. They gotta be brackets. And then what I do is I might bring up both things here. Again, the example we're doing is phosphorus. I'm going to bring up the other map. See if I can get these both on here. That's good enough, I think. Not quite. Whatever. So, I'll do this. There we go. Phosphorus is right here. No, sorry, it's right here. Third row, that's aluminum, that's silicon, that's phosphorus. Phosphorus is right here. So what I did is I went up a row and all the way to the right. So I started at neon, and then I wrote neon in brackets here. So I went up a row, neon in brackets, I'm starting at neon, and what comes after neon, that's where I start with my electron configuration. So here's neon, the thing after neon is right here, 3s. So that's the first thing I write, 3s, and how many boxes? 1, 2. Go straight across, 3p is the next code, and phosphorus is the third one in. 1, 2, 3. Right here is phosphorus, so 3p3. So you can see that this will save a little bit of time here. Instead of starting all the way back at the beginning of the periodic table, all the way back at 1s and building up, I can do a little shortcut. So let's do a couple more examples here. Next example, K. So we're going to do potassium. I'm going to bring up periodic table again. Potassium, fourth row down. Fourth row down in that first column. So fourth row, it is right here. Now, to do the shortcut, again, I go up a row all the way to the right. So I'm going to start right here. What is that? Right here, 3, 1, 2, 3, it's argon. So what I do is I put argon in brackets, and I start counting at argon, which is right here. So after argon comes 4s. And there's 2 of them. Actually, it's potassium, sorry. So 4s, potassium is right here. So it's just 4s1. It's that first box of 4s. So I just 4s1. And that's it. I'm done. Because potassium is K, it's right here. I went up a row all the way to the right. And I started counting at argon. Instead of starting all the way back at hydrogen, I went up a row all the way. I started argon. I am almost out of time, so what I'm going to do is I'm going to pause it real quick, and I'm going to put the answers for the next couple examples up. If you want to pause it now, try the next couple examples, and I'll put the answers up. 1 second. Okay, there is the answer for AS, which is arsenic. I'm going to pause it, and I will do the answer for lead, PB. Actually, we're not going to do lead. I just realized lead is a bit more complicated than we need to get. Lead would actually include the F block down here. The F block fits in right in here in the 1, 2, 3, 4, 5, 6, and 7th row. So we won't worry about that. I did want to point out that your periodic table shows these shortened versions of electron configurations, the shorthand version, but it does it differently. So if you look up arsenic, it's going to say something similar to this, but it's not the same. I want you to do it in the order and the format that I use. So if you just copy it off the periodic table, that will get you marked wrong. You will lose points for that. I want you to do it the pattern, the format that I'm teaching you, which is slightly different from what's listed on your periodic table. But that's about it. If you have any questions, contact me. Stop by first hour if we don't have class, any of that. Thanks.